The law of iterated expectations also applies to expectations that are conditional on multiple random variables. For example, let big X, big Y, and big Z be random variables that are jointly distributed. Then the law of iterated expectations says that big E of big Y equals big E open bracket big E open big Y given X and Z close bracket, where big E open big Y given big X and big Z close is the conditional expectation of big Y given both big X and big Z. For example, in the network connection illustration of table 2.3, let big P denote the number of people using the network. Then big E given big big E of big M given big A and big P is the expected number of failures for a network with age big A that has big P users. The expected number of failures overall, big E of big M, is the weighted average of the expected number of failures for a network with age big A and number of users big P, weighted by the proportion of occurrences, both big A and big P. Exercise 2.20 provides some additional properties of conditional expectations with multiple variables. Conditional variance. The variance of big Y conditional on big X is the variance of the conditional distribution of big Y given big X. Stated mathematically, the conditional variance of big Y given big X is var of big Y given big X equals X. The sum, which equals the sum of I equals 1 to K of open bracket Y sub I minus big E of big Y given big X equals X close bracket squared multiplied by the probability of big Y equals Y sub I given big X equals X. Equation 2.21. For example, the conditional variance of the number of failures given that the network is old is var of big M given big A equals 0, which equals open O minus 0.56 close squared times 0.7 plus open 1 minus 0.56 close squared times 0.13 plus open 2 minus 0.56 close squared times 0.1 plus open 3 minus 0.56 close squared times 0.05 plus open 4 minus 0.56 close squared times 0.02 is approximately 0.99. The standard deviation of the conditional distribution of big M given that big A equals 0 is thus the square root of 0.99 equals 0.99. The conditional variance of big M given that big A equals 1 is the variance of the distribution in the second row of part big B of table 2.3, which is 0.22. So the standard deviation of big M for the network is the square root of 0.22, which equals 0.47. For the conditional distributions in table 2.3, the expected number of failures for the new network 0.14 is less than for the old network 0.56, and the spread of the distribution of the number of failures as measured by the conditional standard deviation is smaller for the new network 0.47 than for the old 0.99.